All right, in this lesson, we're going to be talking about medians and altitudes of a triangle. We've been talking a lot about different parts of a triangle, and these are just two other ways of discussing triangles and parts of those triangles. Okay, so median. We know that word already from the past. We know that that often means the middle number. Okay, the median of the triangle is the same idea. It's the segment that goes from a vertex to the midpoint of the opposite side. So what this does then is it splits the bottom part of the triangle into two congruent spots. Okay, so if you see that this is the midpoint and that these two are congruent to each other and it's connecting to the opposite vertex, then you'll know that it's the median of a triangle. Okay? All right, so we have a theorem that goes along with this vocabulary word. It states if the medians of a triangle are concurrent at a point that is 2/3 the distance from each vertex to the midpoint of the opposite side. Okay? So what that means is, as you can see, we have this particular median right here. I'll draw in, let's just say red, okay? Just so we can see it a little bit better. All right, now, excuse me. This is our point of concurrency, okay? And we're actually splitting the median into two different sections. We're splitting it into a section that equals to 6 and a section that equals to 3. Well, if you were to take this entire median, it would equal 9. Okay, so what this theorem is stating is that this point is 2/3 of the way from each of the vertexes. Okay, so this spot is 2/3 from this spot. Okay, of the distance. It's that easy. Okay, so let's just say this was. So we also have another example here. We have 8 and 4. Okay, 8 and 4. All right, so let's just say this was 9, or let's make it 10. All right, so if this is 10, then we would have another spot right here, and you can figure that one out in your notes, and I'll look for that answer. All right, so the point of concurrency in the medians is actually called a centroid. Okay, so this little spot right here, it's called the centroid. All right, so that's everything I have about medians. Now we're going to switch over to the altitudes. Altitudes. An altitude is the perpendicular segment from a vertex to the line containing the opposite side. Okay? The altitude, as you can see here, it can either be inside the triangle, or sometimes with obtuse triangles, it's outside. Okay? Or on right angles, it's actually part of the triangle. So in right triangles, it's actually one of the legs is considered the altitude. As you can see in this obtuse triangle, we have it on the outside. On this, I would probably call that a scalene triangle, we have it on the inside. Just as long as it's creating this 90-degree angle, it's considered an altitude. Okay? All right, so with this, we have something called the orthocenter of a triangle. The orthocenter of a triangle is the lines containing the altitudes of a triangle are concurrent to the orthocenter. Okay? All right, so that's just another vocabulary word for this particular section. Right, now, so if we wanted to try identifying the medians and the altitude, in this particular picture, what segment would be considered the median and what would be considered the altitude? Well, the median would be VW, and the altitude would be ST in this particular triangle. Now, if you remember, the altitude creates this 90-degree angle. The median creates these two congruent, sections. Okay? So this is all I have for you today. I know it's a lot of vocabulary coming out too, but it's really good for you to get used to this vocabulary because a lot of the problems you'll be dealing with will be saying things like medians, altitudes, orthocenter, centroids. You need to know what they're talking about. Okay? So please have your whisks for me tomorrow. Please include any questions if you have any. Otherwise, I will see you tomorrow and be prepared to work on this.